Hi everyone! Before I take that guitar amplifier chassis and I drill it full of holes for tube sockets and transformers and such, I want to make sure the components that I've chosen for this vacuum tube audio amplifier build work well with each other. So, for example, say I order up an audio transformer that should work well with this tube. I take that audio transformer, mount it to the guitar amp chassis, drill holes for the two tubes, mount the tube sockets, wire it all up, experiment with the values for a while, and find out that I'm very unhappy with the audio transformer, or something like that. Well, at this point, I've already drilled all the holes in that little guitar amp chassis, and I'm going to have issues because the rules would have it that any other transformer that you're going to replace the one that you've purchased will have a different footprint. That's just the way it works. Maybe the windings will be a little bit bigger or something like that, which will mean I'll have to move the tubes over a little bit to keep them away from the transformer. There's always something like that that happens. So in order to avoid turning your chassis into a block of Swiss cheese, the best thing to do is to create an amplifier test bed. I'm going to show you how to do that today in this video. So we'll build the amplifier in that test bed and thoroughly test it out. Now, this test bed will only be the power amplifier section. There's going to be no power supply because we need to figure out what we need in a power supply, first of all, to make this little tube amplifier chassis. So we have to go one step at a time here, and I'll take you through this entire process with me. So right now, in order for me to get an amplifier test bed, the first thing I need to do is figure out the largest component that's going to be on that test bed, and that'll be the audio output transformer. And I need to use this little section right here to figure that out. So I'll just zoom on in to this right here. And as you can see, the effective load plate to plate is what we really want to focus on here. And as you can see, the effective load plate to plate 10,000 ohms is very nice because it gives us, approximately 12 watts out. So we definitely would want something between 8 and 10K somewhere. Now, you can see that since we're going to be dealing with 12 watts, if we're, playing with a guitar amplifier and we're going to drive this thing into heavy distortion, there's a really good chance if this is going to be 12 clean watts, we're going to get 15 to 18 out of the thing in pure distortion. And if you're playing in pure distortion for any length of time with a 12 watt transformer and it's trying to make 18, you might be replacing your audio transformer. So it's always a good idea to overrate the audio transformer. So I would want it to be looking for something, in the 15 to 20 watt range, something like that, whatever's available. So we know 15 to 20 watts and roughly between 8 and 10K. Well, that wasn't so hard, was it? So that's what I'm going to look for. I'll look for all of that stuff. And when I order up a transformer, I'll be right back. Through the magic of the camera, that'll only take a few seconds. But for me, it's going to definitely be a while. Another thing that you might be interested in is CCS stands for Continual Commercial Service. So CCS, Continual Commercial Service. And then down here, yeah, there it is, ICAS. That stands for Intermittent Commercial and Amateur Service. So if you ever find this on a data sheet like that, that's what those two things mean. That's not something that really is talked about a whole lot. So that might be beneficial to know. We'll talk about all of these ratings here in just a little bit as well. You can see that you got to remember the tube manufacturers thinking of their well-being. So they say absolute maximum ratings is 300 volts on the plate and 200, on the screen grid. Well, screen grid might come in close to that, but the plate is going to probably deal with quite a bit more. Again, we'll experiment with this and I'll show you what I come up with here in just a little while. So again, since the vacuum tube companies are not looking for warranty recalls, things like that, they're going to try and run these tubes as easy as possible. So even in a gross overload situation or something like that, running, this amount of plate volts and things like that, the maximum signal, plate current 2 times 50 milliamps. So they're basically talking about each plate, they're really taking it easy on these tubes. So we might be able to, spice things up just a little bit. Let's find out here. So I'll take you through that entire process. But for now, I'm going to get an audio transformer and I'll be right back and I'll share that with you. So I ended up spending a lot of time looking at audio output transformers. I probably spent way more time than I should have. But this transformer here works on many different levels. This is the Hammond 1750 PA. First of all, 8400 ohms center tapped on the primary side, which is right within where we need to be. The transformer gives us the option of 4, 8, and 16 ohm taps. So if you want to change the speaker in your cabinet, this will allow you to do that. It's rated at 18 watts, perfect, and the frequency range is perfect for a guitar amplifier, 70 hertz to 15 kilohertz. If that isn't good enough, it's made in Canada, sold. So this is the transformer that's going to end up, let's move this out of the way, on the amplifier test bed. Now this must be Hammond Day. No, I'm not sponsored by Hammond, but it just happened to work out like this. The 1590D will make a perfect amplifier test bed. This will fit right on here like so, give me just a little bit of clearance, and I can take the tube sockets, mount them in here like so. So phase inverter and output, so I'll center those in here. Inside the box, I'll mount some terminal tie strips so I can tie components, be there, and maybe one on this side inside the box again. And I'll probably put one on this side here as well for the speaker output leads. So the transformer will actually be sitting like this here. These are the speaker output leads, and this is the plate side right here. So I'll get a whole bunch of holes drilled and this thing all mounted with rubber grommets and things like that, and I'll start working on a design, and I'll share that with you in the next shot. If you're thinking of buying tube sockets, these things are available everywhere now. Vacuum tube sockets, 9-pin, 7-pin tube sockets are very common because there's a lot of people building vacuum tube amplifiers. And the thing that changes with these tube sockets is this area right here between the pin and the outside. So sometimes they're a little bit thicker. Of course, the distance between the pins can't change or the tube won't fit, right? But they make the tube sockets wider and thinner, and they've done all sorts of different things. The spacing between the mounting tabs moves around a little bit too. So I'll leave that up to you. You can choose, ceramic tube sockets or whatever you like, and then, drill the holes, to size, to whatever works for you. These are just some that I had sitting in my parts bin. So again, they're available everywhere. And of course, choose the terminal tie strips that you like as well. These are, again, available all over the place as well. This is just an amplifier test bed and stuff that I've had, parts that I've had on hand. The most important thing is this transformer. These are available right now, and so is the box. So you can build this to, exactly the same thing that I'm building if you want to put this thing together. Now, keep in mind, if you're going to build this amplifier, this involves working with high voltage, and you're doing so at your own risk. I'm going to have multiple power supplies running when I'm operating this thing, and I'll be feeding this thing various different B+ supplies. And I'll talk a little bit more about that when I get the amplifier built. So I'm going to do that right now, and when I have a little amplifier built with some components and some schematics drawn for you, I'll be back. And here's the little amplifier test bed all put together. Now, I ended up using this project box here. It's the same size as the one that I showed you. You can see it right here. It's just that I already had some holes drilled in this one here, so I figured why drill this one up if I already have the holes drilled in this one. So they were very close to what I needed. The only difference between this box here and the Hammond is this one here is just a little bit longer. But in a way, the 1590D would be more beneficial because this is just a little bit shorter, easier to get at the components. So at any rate, the Hammond 1590D is still valid. It's just that I use this one. And I've also got a whole bunch of components installed in the test bed already. I've done a whole bunch of experimentation, which leads me to the schematic. So I have a bunch of controls here that I can adjust. And these here just sit outside that I've been using. So one's a feedback control, and the other one balances the amplitude in the phase inverter. So this can be changed with a fixed resistor down the road. So what I'm going to do is get the schematic, and I'll show you the schematic, and we'll take some tests of this little amplifier and see how well it does. I'll attach it to some power supplies. This is the schematic for the amplifier that's built into that test bed. This is available just below this video as an attachment. The difference between this schematic and the schematic that you download, the schematic that you download will have all the component values listed on it. Now, I'm not going to go into great detail explaining the way this circuit works in this video. Reason being is I'd like you to figure that out. Now, you can write down how this circuit works. You can figure out how the phase inverter circuit works. Things like, why are the resistor values on the two plates different in the phase inverter circuit? Why have I made this adjustable? All sorts of little things like that. And I'll explain this all in the next video. I'll go into detail on how this circuit works. Now, you don't need to write your explanation in the comments section, and don't feel like you need to do that publicly. You can if you want, but you don't need to. You can just write this down in the privacy of your own place and then just compare your notes to what I'm about to tell you in the next video. So, this is the 6J6. I chose the 6J6 as a phase inverter because it's a neat little tube. So this is one tube here, and this is one tube here as well. This is the 6360. This is the transformer, the audio output transformer. This here is the bias supply, screen and plate supply. So I'm going to be varying the voltages at this point right here in order to test this amplifier out. Now, I originally designed the phase inverter circuit around a 300 volt supply, and I find that it works well down at 200 volts as well. I'd like to keep the phase inverter supply at 300 volts, so chances are when I design the power supply down the road for whatever power level that we want to set this thing at, I'll have a 300 volt tap in there or something like that at that time. I'll figure that out when that time comes. Really, all that I have to do is, change plate resistors and adjust this right here. So I'll talk a little bit about this resistor as well in the next video. You can see that I've got twisted pair inside running these tubes. The filament section in the 6360 can run at 12.6 or 6.3 volts. Now, in order to run this at 6.3 volts, which is a common filament voltage, I'm using the center tap inside the tube. So you can see pins 4 and 5 are tied together and then run out, and then pin 9 runs out. And then this 6J6 filament is just in parallel with these lines right here. So this is set up for 6.3 volts right now. That's just a quick rundown of the schematic. Again, in the next video, I'll go into detail on how this works, and you can compare your notes at that time. So now let's get to the fun stuff. What I'm going to do is get the amplifier in here and set up some scopes, and let's see what kind of power we can get out of this one 6360 tube with a little 6J6 phase inverter. The moment of truth has arrived for this little amplifier. Let's see how much power this little amplifier makes. I have to warn you though, if you're following along, you're doing so at your own risk. I have all sorts of different supplies running into this amplifier chassis. I have a separate screen supply, which will be around 200 volts DC. I have a separate plate supply running into this chassis, which will be around 300, and that's adjustable as well, so that I can adjust the plate here to demonstrate the different wattage levels and things like that. There's a high current filament supply running into this. There's a negative bias supply, which this will display over here. There's all sorts of different supplies running into this chassis right now to make this amplifier demonstration work. So if you're uncomfortable working around any type of high voltage or anything like that, definitely do not do it. Do not build this chassis or do not build anything in it. If you're following along, you're doing so at your own risk. So, how I have things set up here, there's so many different parameters that I can display. I'm only going to display a bunch of them in this video, and then in the next video, we'll take an in-depth look at the phase inverter and all sorts of different things like that as well. But what I'm going to do is give you an overview, basically a whole bunch of readings just condensed into one right now. So we're not going to look at the phase inverter plates in this video. We'll look at the output. And we'll also look at the bias level, and I'll just tell you what the high voltages are because there's just too many things to get on the screen here in order to do this test. There's so many different things happening. This here is my dummy load across the audio transformer, 3.9 ohms. Now, it's actually very close to 4 ohms. It's about 3.998 when I measured it, so it's a perfect little load resistor right there. My audio signal is coming in over here. This is the filament supply, and this green wire here and this green wire here is the filament supply, and I have negative bias and different B+ supplies and everything running into here, so all sorts of things. This is my feedback control. I can adjust the feedback with this, and we'll probably make the feedback adjustable on this amplifier just because that allows to drive it into incredible amounts of distortion without the feedback control. So you can dial in your own feedback. Kind of neat. And this control right here is just adjusting the amplitude balance of the phase inverter circuit, and I'll display that in the next video. It's pretty well balanced right now. So this will display the wattage output, and again, this is the negative bias. So what I'm going to do, one thing to keep in mind, I have two separate supplies operating the plate and the screen supply, and if I shut the supplies down in the wrong order, I'll absolutely destroy the output tube. So something to keep in mind, if you ever cut the plate supply before you cut the screen supply, the screen will try to act like the plate and the whole tube will just destroy itself immediately. So the screen supply always has to be shut down first. So when I turn this thing on, I'm going to turn the plate supply on first, and then I will turn the screen supply on. I'll get into more of that in the explanation of the schematic and when we take a look at the top side. As I say, this is quite a huge topic to talk about here in this portion of the amplifier design, and I'll try and share as much information with you as I absolutely can. So I'm going to turn on the plate supply right now, and that also turns on the bias supply, which you'll see right here. So I've got about negative 27 volts on the control grid of the output tube right now, and that's set to give me an idle current of about 25 to 30 milliamps on that tube. So it's going to idle that tube at about 25 to 30 milliamps. Now, the high voltage that's running to the plate in here right now is set at 300 volts. Now, I don't have the screen supply on right now, so the tube won't make any power. So now what I'm going to do is turn on the screen supply, and that's going to put 200 volts on the screen. And now the current on my other supply has gone up to about 25 to 30 milliamps right now. So when the screen supply is turned on, it acts like an accelerator. And what that does is that if you have no screen voltage, the tube won't do anything. When you turn the screen voltage on, then the tube really starts to work, because this is a tetrode. So now what I'm going to do is I'm going to turn up the audio signal generator, and we're going to see how many watts this makes until it starts to distort. Now, the supply is 300 volts on the plate and 200 on the screen, so it's very close to the stock values for this tube, and we'll see how many watts this tube makes running in a very safe mode. Okay, so this would be the safest mode that we can give this tube. So I'll turn up the amplitude right now. And as you can see, it's nice and clean at 6.3 watts. And it's starting to clip at about 8.5, 8.7, something like that. 8.3, it's nice and clean. I'd say about 8.5, it starts to distort. Now what I'm going to do is I'm going to crank this thing, the signal generator, right up. So this would be like running this thing into incredible distortion in a guitar amplifier, and we'll see how many watts it makes. So we'll say 8.5 clean and 13 watts into full distortion. And we can even see a little bit of crossover distortion there. So it's kind of a neat looking distortion. So not bad. So stock 8.5. About 8.5 clean, something like that. And then into full distortion, yeah, right now it's about 13 watts. So not bad for just one single tube running at stock parameters. So this would make a nice clean 8.5 watt amp running like this. So now what I'm going to do is I'm going to up the plate voltage to 350 volts. I'm going to leave the screen at 200. And I'll check the bias to make sure it's still the same, and it should remain the same because that's the way tubes work. It's very close. Yeah, it's still between 25 and 30 milliamps. So I'm at 350 volts now on the plate. Screen supply is still the same. Let's see how many watts it makes now. About 11 watts clean. So 350 volts, and the tube, believe me, this tube is absolutely fine at 350 volts. I'm going to show you something pretty amazing with this 6360 tube, and in the next video, I'm going to focus the camera right in on the tube, and I'm going to show you what happens inside the tube when I turn the plate and screen voltages up, so you'll be able to see all sorts of things that aren't explained. And I'll explain exactly what's going on. So lots of neat stuff coming too. So right now, again, there's just so much for this video, I can't fit it all in. So here we go, 10.8, and I'm just going to crank this thing up into absolute distortion, okay? Look at that. 17.6 watts. 350 volts on the plate into full distortion. Pretty incredible for one little 6360. It gets better. I'm now up to 400 volts on the plate, and I need to adjust the bias just a touch. Not much, just a touch. So I'm 400 volts on the plate now, way outside those parameters, and 200 volts on the screen still. Okay, so now I'm going to turn up the signal generator and let's see how many watts this makes clean. It's making 14 watts, maybe a little over 14 watts clean. Say right there is clean. So about 14.5 watts clean. Not doing bad. 14.5 watts clean. That's what that amplifier was supposed to do, but it really, you know, as you saw in the other video, is nothing like that. So that's 14 watts clean. One tube in push-pull. Now what I'm going to do is I'm going to crank this up into full distortion and let's see what it makes. 22.8 watts. So just about 23 watts into full distortion with one 6360 tube. Now here's something that's pretty amazing. I'm going to take that tube's plate voltage up to 450 volts. Now this is further than I would want to run this in reality. It's at 450 right now. Screen is still at 200 volts. Now, honestly, the 6360 tube, if you run the screens at 200, it's fine up here. I've tested so many of these tubes and they're fine. Watch this. It's making 17.3 watts clean right now. That's just about using up that entire audio transformer in clean. And it's fine. It'll do this all day long. That 6360 tube, there's no glowing in the plates. There's no glowing in the screens. Nothing running up at this voltage. No problems whatsoever. And again, in the next video, I'll show you exactly what I mean. So now, here comes the goods. Watch what happens when I crank the signal up. 27 watts out of 16360. Pretty amazing. That little load resistor that's rated at 10 watts right now, I'm pretty sure I could probably almost light a match on that. Might be able to actually. That thing needs to be fan cooled right now. That's why I'm keeping the duration down very short. Again, the tube runs absolutely fine up here. Now, I'll run this down to 400 volts again. And just touch up the bias right there. And give it a little bit more bias at the high voltage here. So again, this is at 400. So as you can see, we get just an incredible amount of power out of this one little tube. And then into full distortion, it goes crazy. Look at that. Adjust that right there again. Adjust the bias. Amazing little tube. Absolutely amazing. So now, again, I wouldn't want to run this tube up at 450 unless, you know, this was an amplifier for myself and I was using this for maybe just audio listening or something like that, because guitar amplifiers put an incredible amount of stress on these things. And of course, we're taking this thing beyond what that transformer is even rated for. I mean, you saw that it was 27 watts worth. So even at 350, you know, something like that, that would be incredibly safe, I think. It's well beyond what they suggest, but, well, they say 300 on the plate. 350 isn't so bad. You know, that still gives us, you know, a nice clean 10 watts, no problems. And then right into full distortion, 17.6. Kind of neat looking crossover distortion right here. Makes some pretty neat guitar sounds. Even there, look at the distortion there. Some nice crossover distortion happening there. Stuff that you don't get in a solid state device. You don't see that in that TDA IC. Now, of course, crossover distortion can be created in any type of a scenario, even with solid state stuff, but you won't see that in an IC. It was turned into just a really crazy looking square wave. So all sorts of neat opportunities with this. Let me know in the comments below what you think we should build this at. Should we keep it super safe, run it low, you know, keep the amplifier, you know, like a small amplifier, or do you think we should try and run the vacuum tubes hard? Chances are what I'm going to do is, in my previous videos here on Patreon, I released a very neat little high voltage regulator circuit that uses a really small transistor and a FET. And when I design the power supply for this, there's a good chance that I'm going to make a variable power supply for it. So you can basically dial up what you like. Okay, so you can experiment with your tubes. Now, there's some interesting things about these particular tubes. What I'm going to do is I'm just going to shut the power supplies off. So I have to be very careful. Screen supply off first right now. Screen supply is off. Wait till that goes down right to nothing. And now I'm going to shut off the plate supply. Again, if I shut that off in the wrong order, I will absolutely turn that tube into a flash cube. And I definitely don't want to do that. So now all the high voltage is missing off this thing. You can see these tubes here. The 6360 tube is a really nice looking tube when it's operating too. See if I can get that into the camera shot there. Maybe I can put something under here to support that. Let's get something under here. Maybe this RCA tube box. Will that do it? No. What can I get under there to support it? I don't have anything here that's going to do it properly. Maybe this pin. No, there's nothing that's going to support that like that. At any rate, here, I'll shut this off. You can see, like, what a nice looking vacuum tube that is. It lights up. That cathode in there is so bright. And in the next video, I'm going to focus right on into this, and I'm going to take a tube. I have a bunch of tubes that are kind of gassy, and I have one that's actually faulty itself. And what I'm going to do is I'm going to run that thing into basically till it destroys itself, and I'm going to show you what happens in this tube and the things that you need to look out for in any type of a vacuum tube amplifier that uses a glass type tube. You can see these effects in 6L6s, 6V6s, EL34s, KT66s, KT88s, any type of audio output tube that's glass. You can look through the glass and you can tell what's going on in there. You can tell if there's too much screen voltage, if it's drawing screen current. You can tell if it's gassy. You can tell if there's, you know, if it's dealing with a little bit too much plate current, all sorts of things. So I'll show that all to you here coming up very, very soon. So you can let me know in the comments below. What do you think? Should we run this thing super safe? Should I make that variable power supply and just allow you to basically dial a watt or dial some power, I guess you could call it? Do whatever you want with the power supply. Just let me know in the comments below. So, oh, I didn't display the feedback control. I'll display the feedback control here quickly, and I'll talk about that more. That's attached to the phase inverter circuit. I'll talk about that a little bit more in the next video. So I'll turn everything back on. Everything is good here. Let's go. Probe is hooked up. We're at 350 still. That's fine. I'll just turn this on. Okay, so now, when I turn the feedback control up, of course, when you add negative feedback, it's going to reduce gain. Reducing that gain will also get rid of a lot of distortion, and it also will help with the frequency response of the transformer. It won't make it have such a peak in the response. And I've explained a little bit about this in other videos, so what I'll do is I'll just turn this up a little bit right now. Now I'll just give this a little bit of feedback. So you'll see what will happen here. You can see it'll knock the wattage rate down as I add the feedback. So I can take that down to about 5 or 4 watts. So you can see, like, I mean, we've lost half the wattage out just by adjusting the feedback. But we're going to gain other things in return. We'll get lower distortion. So if you like to play really clean, so now I can turn the gain up, and it'll really clean that sine wave up. So for clean playing, if you like to play absolutely clean, adding feedback is the thing to do. And then, of course, if you want full distortion, I can just turn this down, and of course, this will go crazy right now. So there you go. That's nothing. We're up to 13.5 right now. So can dial that in. Kind of a neat feature. And if you give it too much, you'll run the thing into a little bit of an oscillation. So I don't have an end on this. I don't have a stop on it. So technically, if I add a bit of a stop to it right about, I'd say about there. So give this a little bit of series resistance here. It won't allow me to bottom this into an area where it'll run this into an oscillation. So basically too much feedback. Now, when I said motorboating here on this schematic, it's another thing I should explain. So when I say motorboating, you'll see here it says plate lead reversal will cause motorboating. So motorboating is just a term for oscillation. It makes a motorboating noise, kind of a slow oscillation. So if you have the blue and the brown lead reversed and you apply the feedback, it's going to run this, it's going to turn it into an oscillator. So what it's going to do is it's going to start to motorboat, and by you varying your feedback control will vary the oscillation rate. So what you need to do is make sure that the plate leads are right, and that's why on your schematic, the plate lead colors are listed here so that you can attach the appropriate phase inverter output from the plate to the correct tube that has the correct colored lead on it. If you reverse these leads, again, you're going to make yourself a pretty nice oscillator, things like that. So what else can I tell you here? That's about it. So just back the feedback right off again. That's just opening that VR and just turn this down. The resistor's getting nice and toasty. So there you have it. So again, you've seen what that little tube can do. It's actually incredible. It's really surprising. And some of the tubes will take 250 volts on the screen. Now, it's a very small amount of them will take 250 and be just fine with that. I have one tube that will take 300 on the screen, and the screens don't glow. I get no color, no anything happening. Now, contrary to what you may think, when you turn the control up, just say the plates are glowing in this because the bias is wrong or something like that. When you make the tube actually perform, when you make it oscillate by giving it a 400 cycle signal, when it's oscillating, that red plate will actually go away, right? Because it's oscillating. It's not just sitting there static. And then if you shut the audio signal off, you'll see the red plates glow again. So contrary to popular belief, red plating is usually in the absence of a signal. It's the same thing that happens in the horizontal deflection section of old televisions. When the oscillator failed, the horizontal output tube would virtually melt itself. So the plates would glow orange hot and the glass would actually cave in. I have a vacuum tube where that's happened. There's big dips in the glass. The glass is actually melted on the tube. I'll see if I can find that, maybe display that in the next video. So I don't know where I put it, but I do have one somewhere. I had to keep it because it looked so interesting. It looks pretty bad. So that tube obviously failed in a really bad way. So anyways, there you have it. Leave your comments in the comment section below. If you're enjoying this video series, don't forget to tap the heart symbol. And I'll talk to all of you very soon with some very neat information in the next video. Bye for now.